Dear students, in continuation of the previous video, which I have recorded, and about the passive components which we discussed in Unit 1, and continuation of this, okay, let us, we know about the two different types of signals available in electronic circuits. The one we call it as alternating current signal or AC signal, and another one is called DC signal. The main difference between an AC signal and a DC signal is AC signal has a frequency, and the frequency is nothing but a number of cycle per second. Always it is measured in hertz. So how many cycles it has in a second? So that much is the frequency of the signal. Whereas a DC signal has a frequency 0. It is always represented as a constant. It has no cycle and no frequency. And then you can say, what is the frequency of DC signal? If someone asks, the frequency is 0. And please remember in this one, it has a positive and a negative half cycle, and positive and a negative, one positive and one negative half cycle makes one cycle. So please remember, and continuation of this is about the DC, as I informed you that DC has no frequency and hence it has no cycle. Please remember, that's very, very important. So the cycle is 0, frequency is 0, and it has a 0 hertz, and it is a steady DC supply. Normally, all the electronic circuits requires a constant DC supply. So that means there should not be any variation in the signal. So the best example for the DC current we can say is our electronic devices uses a DC power supply which gives a constant voltage. So throughout as long as the device is on, it gives a constant supply. So that is an example of direct current. And in a home, we use, normally we operate many electronic devices with the main AC power, and that is a changing values. Okay, fine. And some of the characteristics of AC signal, when we talk about AC signal, some of the characteristics we can say called period, frequency, amplitude. Amplitude is, one thing we can also say in a simple way. We can say it is the height of the signal, or the magnitude or intensity of the signal. Height. The frequency, the definition of the frequency as it is, number of times the waveform repeats itself within 1 second, and number of times the waveform, in a sense, number of times the positive and negative half cycle repeats in 1 second, we can call it as a frequency. And then period. The period is the time taken to complete one cycle, start to finish. Then that is called this. So this is also you are going to study here, and so this is about the AC waveforms, how it is represented. And apart from this AC waveform, we have other types of, it is called a periodic waveform. There are two types of waveform. We call it as periodic and aperiodic. That means, periodic waveforms which has follows the similar type of pattern throughout the period. So, for example, the 4 example we have given. When you look at this, waveform, you can say that about sine wave. It follows the same pattern. Triangular wave, then some complex wave, but it has a pattern, and it is over a period of time the pattern is similar. Then you can see the square wave, and square wave has on and off period. That is also, it has follows the same pattern. Normally, this another important point or thing which you are going to study in this unit 1 is about the calculation of the frequency and time. Please remember, the frequency and the time is complementary. In a sense, frequency is 1 by t, where t is 1 by m. If you know the frequency, you can calculate the time period of that signal. So if you know time period, you will know what is the frequency of the signal. So all this we are going to study. And coming to this now, this is a very important concept or the which you are going to study in this unit one is how to analyze the electronic circuits and what is the meaning of analysis. So please remember in your thing that the to analyze the circuit means you have to analyze about its voltage and about its current. How to analyze or how to measure voltage in a circuit, how to measure a current in a circuit. So these two, voltage and current, plays a major role in any of the circuit. And normally we follow some universal law. In a sense, this law is universally applied anywhere, like Ohm's law and Kirchhoff's law. It is about general application to the circuits. Means if you have a circuit, you want to know what is the voltage, what is the current, definitely you can apply this Ohm's law and Kirchhoff's law. Okay, again in Kirchhoff's law, you are going to study about, there are two laws, we call it as Kirchhoff's current law and Kirchhoff's voltage law. One is about node voltage or at the node, is another is about the junction. So more on this we are going to learn in detail in the coming classes. The two types of this. Then the another question will come here is that see the circuit, when we talk about the circuit, we say it is from simple circuit to complex circuit. Simple circuits are very easy to analyze. But if the complexity of the circuit increases, then to analyze the circuit is becoming very difficult. Then applying Ohm's law and applying Kirchhoff's law is very difficult for a circuit which is very complex in nature. So in that, then we are going to study about the various network theorem. It is used to analyze a complex circuit. Means just how to measure voltage and current. Some of the network theorem which you are going to practice, which you are going to study, and which you are going to calculate, or which you are going to analyze is Thevenin's theorem, Norton's theorem, superposition theorem, and maximum power transfer theorem. Of course, I'll give you just a brief introduction. What is Thevenin's theorem? Thevenin's theorem is a type of theorem which we apply to a complex circuit. So in this, that complex circuit is converted into a simpler circuit is having Thevenin's voltage and Thevenin's resistor in series with that. And everything, the entire complex circuit is converted into one voltage source and one resistor. So that is about you are going to study. Similarly, in most of the circuits, it is very important to know the maximum power, how much is the maximum power of the circuit, so that you can utilize that power. So this maximum power transfer theorem which explains to you that how much maximum power which delivered to the output. So this is another network theorem which you are going to study. Then another type is called superposition theorem. Superposition means combining two things, or it is actually a superposition theorem is an extension of Ohm's law, because Ohm's law is applicable to most of the simpler circuit. Suppose if you go for a complex circuit, definitely then the superposition theorem which helps you to analyze from this superposition theorem. So, and the Norton's theorem, this is again it is similar to Thevenin's theorem, but there is a difference between a Thevenin's theorem and Norton's theorem. Thevenin's theorem is about the voltage, Norton's theorem is about the current. And here also, Norton's theorem, the complex circuit is converted into a simpler circuit having a current source and a resistor connected in parallel. So this entire thing, about the theorem and about the universal law and the problems based on this, all this you are going to learn in this unit. And This unit 1 covers the passive components, its function, its characteristics, and AC and DC signals, and about the network theorems, what you are doing, and there are the number of problems which you are going to do in this unit. Okay, so thank you.